Imagine like a single $20 bill leaving your wallet because you're paying for some monthly AI subscription, right?
Right, yeah.
Where does that actual physical money go? Because we are just constantly bombarded with these massive headlines about AI hype.
Oh, totally. Every single day.
Yeah, every day it's a new story about, astronomical infrastructure costs or these giant data centers that are basically eating entire towns. And the global stock market has pinned this, and this number is wild, a $22.7 trillion valuation on this tech.
It's a staggering number.
Right. But I want you to really think about the trillion-dollar question today, which is anyone actually making real money off this?
Well, it's really the defining financial mystery of this decade. I mean, without a doubt, we can very clearly see the billions going in, but tracing the actual revenue coming out has been incredibly difficult.
And that is exactly our mission for this deep dive. We're unpacking this really fascinating June 2026 report. It's called The State of the AI Economy by Azim Azhar and the team over at Exponential View.
Yeah, it's a brilliant piece of work.
It really is. So the big picture here is that we have this massive visibility problem. The supply side of AI, it's super obvious. When a chip maker sells silicon or, a giant public tech company builds a data center, they shout those numbers from the rooftops during earnings calls.
Exactly, because it pumps up their stock.
Yeah.
But the demand side, what you or me or these massive Fortune 500 enterprises are actually paying for the end product, that has been completely obscured in private labs and just, hidden inside tech giant revenues.
Right, which creates this totally dangerous blind spot. If you can't measure genuine customer demand, you just can't judge the actual health of this AI economy.
Yeah, guessing the size of a software market just by looking at how many raw computer chips are being bought,
Mhm.
it's kind of like trying to guess the revenue of the entire restaurant industry by counting how many industrial ovens got sold this year.
Oh, I love that oven analogy. That's perfect.
Right. I mean, it tells you about capacity, sure, but it tells you absolutely nothing about how many people are actually sitting down and buying dinner.
Exactly. So to understand how much money is actually being made on the meal, we first have to explain why the numbers have been so messy up until now. Because the Exponential View report, they treat this like an exclusive peek behind the curtain of this huge stock market mystery.
So the primary hurdle here in tracking AI revenue is this really rampant double or even triple counting of the exact same dollars.
Yeah, it's a mess.
It is. So the researchers at Exponential View, they spend months building this bottom-up, line-by-line financial model covering over 1,000 different firms.
Oh.
And their core innovation, the thing that fixes the lens, is a methodology they call deduplication.
Deduplication. Okay, so think of the current reporting of AI revenues like Russian nesting dolls of venture capital, right?
Yeah, that's a great way to put it.
Everyone in the tech stack is just trying to claim the exact same dollar as their own top-line revenue just to impress their investors.
Exactly. Let's trace a single transaction just to see how that nesting doll effect really distorts the market. So say a customer spends $100 on a license for a new AI writing app.
Okay, $100. Got it.
That app company, they don't build their own AI from scratch.
Yeah.
They rent it. So they pay, say, $60 of that revenue to a foundational model provider, like an Anthropic, right, just for access to the system.
Right.
But then that model provider has to actually run their massive system somewhere, so they turn around and pay $30 to a cloud host.
Like AWS or one of those newer neoclouds.
Exactly, like CoreWeave, which are essentially just specialized data centers built strictly for AI processing.
Right. So in a sloppy, unverified financial model, the writing app claims $100 in AI revenue.
Yeah.
And the model provider points to their balance sheet and claims $60.
Right.
And the neocloud host claims $30. So suddenly, some tech blog adds it all up and runs a headline like, AI industry generates $190 in explosive growth.
Which is just mathematically false. They didn't generate $190. The only new money actually entering the system from the outside world is that original $100. So this deduplication fix strips out all that internal transfer money. It only counts the actual value add at each specific layer.
Okay, but wait. If we're rigidly grading these companies and stripping out all this double counting, aren't we just going to be left with a much smaller, kind of disappointing number?
You would think so, right?
Yeah, because taking away all that Russian nesting doll fluff, it sounds like a recipe for a totally deflated market size that might actually terrify investors.
Well, the counterintuitive part of this really rigorous scoring system, where they, grade audited filings the highest and actively filter out all the Silicon Valley rumor mill stuff, is that it's exactly why the final number is so shocking.
Really?
Yeah, because even after filtering out all that fluff, the demand proves to be incredibly real. It's not just a house of cards built on tech companies trading the same venture capital dollars back and forth. The bedrock of this revenue is actual external customers paying cash.
So, meaning when you pay your $20 subscription for a consumer AI tool, or, when a massive logistics company signs a huge enterprise deal to route their shipping trucks, this model is actually tracking that real deduplicated money flowing down the stack.
Exactly.
Okay, so now that we know the measuring tape is hyper accurate, what did it actually measure?
The reveal is massive. The report found $110 billion in banked, trailing 12-month revenue.
Wow.
And just to be completely clear on the scope here, that figure entirely excludes the Chinese market, which is, as you know, a massive parallel ecosystem on its own.
110 billion in actual verified cash through the door over the last year, just outside of China.
Yes. But the trajectory is, it's perhaps even more important than the banked cash.
Right, the speed of it.
Because of the sheer velocity of this market right now, the annualized run rate, meaning if you take the most recent highest earning month and just project that pace forward for a full year, it is currently sitting at a staggering $175 billion.
A $175 billion pace. Let's just put that growth into perspective for a second, because this is where the speed of this technology just totally breaks your brain.
It really does.
AI is growing 3 times faster than any prior information technology wave. Like, it is scaling faster than the dawn of the internet in 95.
Yeah.
Faster than the mobile app boom when the smartphone launched in 2007. Faster than that massive enterprise shift to cloud computing in 2010.
And the report highlights this one statistic that I think perfectly captures this unprecedented velocity. So back in 2023, it took the AI industry 180 days to add $1 billion in cumulative revenue.
Okay, 180 days.
Fast forward to today, it takes less than 2 days.
Wait, less than 2 days to add $1 billion?
Less than 2 days. The industry is adding revenue 90 times faster than it was just a few years ago.
That is just every 48 hours, another $1 billion of actual deduplicated revenue is added to the pile.
Exactly.
And this growth is holding remarkably steady, right? Like 35% quarter over quarter. Compounded, that's equivalent to growing 3.2 times annually.
Which is astronomical for a market this large.
But what really stands out to me is that this growth has held steady across very different eras of the tech itself.
Yeah, that's a great point.
Right, because we moved from the early chatbot era where everyone was just like subscribing to text generators all the way into this new agentic coding era where AI agents are actually operating independently. They're writing, testing, and deploying complex software. And the revenue engine just didn't stall during that transition.
No. It points to a sustained multi-phase expansion. It's not just a single viral consumer moment that fades away after a few months.
Okay, I do have to play skeptic for a second, though.
Sure.
Because it's always easy to sprint the first mile, right? A lot of corporate executives are absolutely terrified of being left behind by their competitors.
Oh, FOMO is very real.
Exactly, the FOMO. So are we sure these aren't just desperate Fortune 500 companies throwing, short-term pilot money at the wall just to see what sticks? How do we actually know this is sustainable demand and not just corporate fear of missing out?
Well, what's fascinating here is that the data points really heavily towards sustainable demand because of how this revenue is manifesting in the physical world.
What do you mean?
It's showing up as massive multi-year contract backlogs for the hyperscalers. The giant cloud providers like Microsoft, Google, Amazon.
Oh, right.
The demand for compute power is so high right now that global supply simply cannot keep up. And companies do not sign binding multi-year infrastructure contracts for lightweight, desperate pilot programs.
That makes sense. You don't in for 5 years just to test a chatbot.
Exactly. Those backlogs indicate an ecosystem that is deepening. Businesses are moving way past experimentation, and they're actually integrating these models into their core daily operations.
Okay, so the revenue is undeniably massive. 175 billion annualized is a mountain of cash. But so is the spending.
Oh, absolutely.
We have to follow the money to the other side of a ledger to see if the AI economy can actually pay its own bills. Because the physical build-out required to support all this is definitely not cheap.
No, it's comfortably the largest infrastructure build-out in the history of the technology sector. The hyperscalers and those specialized neoclouds we were talking about earlier, they are committing to an astonishing $2 trillion in cumulative capital expenditures. commonly called CapEx through 2026.
$2 trillion. Just to define that for you listening for a moment, CapEx isn't like money spent on salaries or marketing. This is money spent on hard physical assets. Buying the silicon chips, laying the fiber optic cables, literally pouring the concrete for the data centers.
Right.
Which brings us to arguably the most critical question in the entire global economy right now. Can AI revenues actually cover a $2 trillion physical buildout?
Well, according to the report's line-by-line financial modeling, the math actually holds up. The revenues attributable to the hyperscalers are currently just about clearing their depreciation expense.
Okay, let's look closely at that depreciation schedule because this is where the accounting really meets reality. Depreciation is basically how accountants spread the massive upfront cost of an asset out over its useful lifespan, right?
Exactly.
So the report says compute assets, meaning the actual AI GPUs themselves, are being depreciated over 6 years. And the other infrastructure, like the data center buildings and the cooling systems, those are being depreciated over 14 years.
Yep, that's the standard they found.
Here is where I have to push back hard on this math.
Okay, go for it.
6 years. I mean, in AI time, 6 years is a century. A microchip from today is going to be an absolute dinosaur by 2032. How can they possibly justify a 6-year timeline as a fair way to calculate if they're breaking even?
It does sound incredibly counterintuitive, especially given the rapid release cycles of new models. But the report justifies that 6-year timeline with two very specific operational realities from the ground.
Okay, what are they?
First, as we mentioned, demand is vastly exceeding available compute. When an industry experiences a massive compute famine like this, nobody throws away last year's hardware.
Oh, it's like keeping an old beater car running because you desperately need a vehicle just to get groceries, even if it's not the sports car you're taking on the highway.
That's a very apt comparison.
Yeah.
The newest, most advanced chips, they are strictly reserved for the incredibly intensive task of training new frontier models.
Right, the heavy lifting.
But once a model is actually trained, it takes significantly less power to run it for everyday user queries, a process called inference. So those slightly older chips, they're greedily consumed for inference or parallel processing or background data formatting. The market is starving, so literally every tier of hardware gets fully utilized.
Okay, that makes sense. They filter the workloads down to the older chips. So what's the second reality?
The second operational reality is that the data center operators are getting vastly better at managing their massive GPU fleets.
Oh, like software efficiency.
Exactly. The orchestration software that dynamically routes workloads across hundreds of thousands of chips is becoming highly efficient. By reducing idle time and managing heat loads better, they are physically extending the economic life of the hardware.
Wow.
Yeah, the report explicitly notes that this improved fleet management alone provides enough margin to justify lengthening the depreciation cycle to 6 years.
So they aren't just like cooking the books. They're genuinely engineering ways to squeeze every single drop of utility out of the hardware.
Precisely.
Which brings us to that 14-year depreciation schedule for the non-compute infrastructure. And we aren't just talking about metal server racks anymore. We're talking about the actual physical terraforming of our natural environment.
Yeah, we are shifting from counting digital dollars to measuring physical megawatts.
Exactly. The scale of the physical growth happening right now is just, it's difficult to comprehend. For half a century, global compute growth followed this relatively predictable upward trend.
Right.
But AI has violently spurred an uptick in that 50-year trend line. By 2026, we're looking at a projected 9x increase in total world compute, specifically driven by the installation of these massive AI server clusters.
And to house a 9x increase in global compute, the data centers themselves are mutating. The Exponential View report points out that the sheer size of the largest data centers has grown 50 times over in just the last 4 years.
50 times. I mean, these aren't just large office buildings anymore. They're the size of automotive manufacturing plants.
Yeah, they're sprawling campuses.
But a giant building full of silicon doesn't run on nothing.
No, it runs on power and immense amounts of it. This is where the digital AI economy is just violently colliding with the physical economy in a way we really haven't seen since the Industrial Revolution.
It's wild.
Consider this. From 2008 all the way to 2024, the United States power sector experienced essentially zero growth. Energy demand was completely flat. Yeah. Mostly due to efficiency gains in appliances and lighting.
So the U.S. power grid was essentially asleep at the wheel, just cruising on autopilot for 16 solid years.
Then the AI boom arrived. Now, driven purely by the demand from these massive data centers, the power sector is growing by 9 terawatt hours per month annually.
Waking a sleeping giant doesn't even cover it. AI hit the turbo button so hard that the physical grid is actually buckling under the pressure.
It is.
The report contrasts two really fascinating examples of how tech companies are frantically trying to feed these giant data centers. On one hand, you have this massive site called Rainier being built in New Carlisle, Indiana. They're executing a 2.3 gigawatt build via the traditional public power grid.
Right, this standard way.
But to put that in perspective, they are spending over $150 million just on the transmission lines and the electrical substations required to step down that massive grid voltage so the servers can actually use it.
It's a traditional, albeit unimaginably massive civil engineering project.
Yeah. But then you look at xAI's Colossus data center. They literally couldn't wait for the bureaucratic, multi-year queue to get grid interconnection. The traditional grid just moves far too slowly for their development cycle.
Yeah, the video.
They built an off-grid, roughly 1 gigawatt site powered directly by gas.
Wow.
They are hauling in their own massive mobile power plants just to skip the public utility line. I mean, the sheer audacity of a tech company acting like a sovereign utility provider is wild.
It is wild, but it's also a really vital piece of evidence regarding the financial health of the industry we discussed earlier.
So.
Because large load power procurement like this is not purely usage-based. It's not like your home electricity bill where you only pay for what you turn on.
Right.
When you build a site like Rainier, you are required to sign fixed capacity commitments and take or pay minimums with the utility companies.
Oh, meaning if a tech giant suddenly decides AI is a fad and turns all their servers off, they still owe the power company a fortune for the massive grid upgrades that the utility had to build to support them.
Exactly. They're on the hook regardless.
Yeah.
This proves that the hyperscalers are locking in long-term hard asset bets. They're not just buying flexible software licenses that they can cancel next month if the market turns.
Yeah.
They're committing billions in uncancelable energy contracts because their internal models foresee a 14-year horizon of relentless demand.
But okay, so if the physical costs are this astronomically high, building off-grid gas plants, dropping $150 million just on electrical substations, common sense kind of dictates that the price of the AI you and I actually consume has to skyrocket to cover those costs.
Right.
But in reality, the exact opposite is happening.
Yeah, to understand why, we have to look at the token, which has really been the raw material, the fundamental unit of value for the AI economy.
Right, and just as a reminder, a token is roughly equivalent to a chunk of a word or, a few lines of code. It's the basic unit of compute that models use to process and generate information.
Exactly. And according to the Epoch Capabilities Index and the pricing data cited in the report, the blended price of 1 million tokens has crashed from $17 down to roughly $2.
An absolute free fall in price. But wait, if the price of the core product is crashing by over 80%, doesn't that inherently destroy the revenue models of the AI companies?
You'd think so.
Yeah, like how can they hit a $175 billion run rate when their product is getting cheaper by the day?
Well, it comes down to a classic economic principle, the elasticity of demand.
Okay.
The data shows that for every 10% price cut in the cost of tokens, there is a corresponding 12 to 18% increase in the total volume of tokens used by consumers and businesses.
Ah, so the math works in their favor. If the price drops 10%, but people buy 15% more, your total revenue actually goes up, not down.
Exactly. As the tech gets cheaper, previously uneconomical applications suddenly become totally viable. If analyzing a massive 10,000-page legal document wasn't worth doing when it costs $17 for 1 million tokens.
It suddenly becomes a total no-brainer daily workflow when it only costs $2.
Precisely. The falling price expands the surface area of what the technology can actually be used for.
Right.
However, the Exponential View report argues we're reaching an inflection point where the token itself might actually be an obsolete unit of measurement going forward.
Really? Why change the metric? If a token is how they measure compute and it's how they bill us, doesn't it make sense to keep tracking it?
Because a simple count of tokens no longer captures the actual value being delivered by the newest generation of models. The report suggests we need to shift to measuring an intelligence quotient.
An intelligence quotient.
Yeah, a metric that accounts for token volume, certainly,
Yeah.
but also factors in the visible outputs to the user and, most importantly, the actual cognitive capabilities of the models.
So what does this actually mean for you listening? If the price of intelligence drops to a fraction of a penny, how does that change our day-to-day behavior? Do we just, like, consume infinite AI? Will everything we touch, from our email inboxes to our thermostats, just be thinking and processing all the time?
The behavioral shift is really profound. Cheaper AI doesn't mean businesses just perform the exact same historical tasks and pocket the savings.
Great, they expand.
Exactly. It means we aggressively expand its use into a much wider, deeper range of economically useful tasks. We're no longer just paying for a final, instant output like
Yeah.
a drafted email or a quick block of code.
Yeah.
As models transition from simple pattern matching to complex reasoning, they actually spend massive amounts of tokens internally before they ever give you an answer. We're increasingly buying the internal thinking time of reasoning models.
So we are essentially paying the machine to sit there, run through thousands of parallel scenarios, and ponder a complex problem before it speaks.
Yes. And that internal pondering consumes vast, unprecedented amounts of compute power. So even as the price per individual token plummets towards zero, the total volume of compute required to provide that deep reasoning skyrockets. The demand doesn't just widen, it deepens fundamentally.
Okay, let's pull all these threads together and just recap the journey we went on today. We started by confronting a massive visibility problem, completely obscured by these nesting dolls of tech industry revenue.
Right?
But when the Exponential View team stripped away the double counting, we didn't find an empty hype cycle. We found a $175 billion cash engine.
An engine that is accelerating faster than the early internet, and most importantly, generating enough real, deduplicated revenue to cover its own historic capital expenditure bills.
And we saw how that surging digital demand is violently altering the physical world, literally shocking the U.S. power grid out of a 16-year slumber and forcing companies to drag mobile gas plants into fields just to bypass the grid entirely.
It's incredible.
All while the fundamental unit of the AI itself gets cheaper, driving demand even higher. So the next time you read a pessimistic headline calling AI an unproven financial bubble, you now have the hard, deduplicated map to know exactly where the demand is coming from and proof that it's actually paying its physical bills.
Yeah, it's a foundational reshaping of global infrastructure. It's not merely a software trend that can be uninstalled.
So true. And I want to leave you with one final, totally provocative thought from the report to mull over.
Oh, this is a good one.
The researchers note that despite this staggering $175 billion annualized run rate, AI revenue is still, in the grand scheme of things, essentially a rounding error compared to total global GDP.
Yeah, it remains a very small fraction of the total macroeconomic picture.
So think about this. If a mere economic rounding error is already enough to resurrect the entire U.S. power grid, if it requires a $2 trillion infrastructure build-out, and if it forces tech billionaires to build their own private power plants, what exactly is the physical world going to look like when AI isn't a rounding error anymore? What happens to our physical environment when this tech becomes 5, 10, or 20% of the global economy?
It's a huge question.
Where do we physically put all the concrete, the server racks, and the power lines? Because the real gravity of AI isn't just in the financial numbers we finally learned how to see today. It's in the massive physical footprint that is about to cover the world we live in. Something to think about next time you spend a few tokens.